This is a summary on carbon nanomaterials, which is a topic that you have done in chapter 8. So I hope with this information, you have a better understanding of the concept that you have done on this particular chapter. The first concept that we're looking for today is diamond. There are three things that you need to know about diamond. Number one, we know that each carbon atom has 4 covalent bonds, and within diamond itself, it only consists of carbon atoms. And these carbon atoms are very strongly bonded to one another. And that brings me to point number 2. It exists as a covalent network lattice structure. So if you come across diamond, and we know that diamond is used as jewelry, and it also been used as jewelry apparatus. And the reason for that is because of this covalent network lattice structure that makes this diamond very strong. So if you have diamond today, you can drop it on the floor and it will not break. And the reason for that is because of the strong covalent bonding that it has within its structure. The second concept that you're looking at for today is on graphite. So there are three things that you need to know about graphite. Number one, we know that graphite consists of carbon atoms as well, but in this case, we have each carbon atom being covalently bonded to 3 other carbon atoms. And you may ask the question, what happened to the 4th bond? The 4th valence electron from each carbon atom will be able to move within the layer. And in this particular case, graphite exists as a covalent layer lattice structure. It's different from diamond. Diamond exists as a covalent network lattice structure, but for graphite, it exists as a layer structure. So you can try and picture it that you have one layer after another, and the 4th valence electron allows it to slide past one another. That's the reason why graphite can conduct electricity. And at the same time, it is also being used as lubricants, tensor, and reinforcing fiber in addition to electrodes. Why it can be used as pencil lubricants? Because of its ability to slide past one another, which is the reason why if you pick up a pencil today and if you try and scribble it on the paper, you can see that you can write on the paper. The reason is because you have graphite that is being slid out of that particular pencil. So now we are on the third concept. The third concept that you need to know for today is known as Fullerene. And there is another name for Fullerene. It's also known as the Buckyball or the Buckminster Fullerene. So what is a Buckyball? Sounds familiar? It probably looks like a soccer ball. So you have 3 covalent bonds to each carbon atom, and you also have a 4th valence electron here. But the difference between Fullerene and graphite, that in Fullerene, even though it has the 4th electron, that 4 electrons can't really move around because this exists as a discrete structure. So if you think back on what we have discussed for diamond, it exists as a carbon network lattice structure. For graphite, it exists as a carbon layer lattice structure. For Fullerene, it exists as a discrete structure. Sometimes Fullerene can conduct electricity if metal ions are present. That's the reason why it can be used as a photovoltaic cells. It can also be used as a cage to hold drug molecules, as you can see in this particular diagram here. So that particular drug is a green in color, and then it gets trapped by the cages. When it goes into your body, it can be released into the body cells. The 4th concept that we're looking at for today is known as graphene. So there are 3 things that you need to know about graphene. Number 1, we know that graphene consists of a single atom tip layer. It looks something like graphite. So you can try and picture that you have one carbon atom being covalently bonded to 3 other carbon atoms, but instead of having multiple layers, you only have one layer. So it is just one atom tip layer. But in terms of the arrangement, it's very similar to what you have done on graphite. Number 2, we know that it is easily molded and flexible. It has high tensile strength, and it can be spun into wire, which means it is darter. So what are the uses of it? It can be used as photovoltaic cells because it is capable of conducting electricity. Bear in mind, it still have the 4th valence electrons that enable it to conduct electricity. At the same time, it can be used as electrodes, and it can be used to make flexible devices as well, such as the foldable phone that you probably have come across in the market nowadays, or towards the future, that you will be able to use one of the foldable phone. So it is made of graphene because of its flexibility, even though it still have the high tensile strength. The final concept that we're looking at for today is known as the carbon nanotubes. So 3 things that you need to know about carbon nanotube. Number 1, we know that it is an intermediate between Fullerene cages and the flat graphite. So you can try to picture that it is of a single atom thick layer. At the same time, in terms of the cages, it is of the Fullerene structure. Number 2, it has electrical and thermal conductivity, because for carbon nanotube, it still has the 4 valence electrons that enable it to conduct electricity, which is why it can be used as electrical circuits because of its electrical conductivity as well as its ductility. You are still able to bend it, and in this case, to be drawn into wire. It can also be used as space elevator because of its high tensile strength and electrical conductivity as well. As you can see in this diagram, this is an example of space elevator. Maybe in the future, when we create one space elevator, it will look something like this, and it will be made of carbon nanotubes. So there are many uses to carbon nanotubes in this particular case, but the most prominent one is that because of its electrical and thermal conductivity, it can be used to be made as electrical circuits and space elevators.